I'm the Assistant Director of Samuel Tech Lee Real Estate Entrepreneurship Lab, and I will be your moderator today. So across the world, big cities is experiencing housing crisis. And Patrick just showed me a picture yesterday about a Google engineer lives in a mobile home on the street due to the lack of appropriate housing. And coincidentally, we also read news about a 23-year-old Google engineer lives in a truck parked in Google's parking lot and saves 90% of his salaries. So some statistics shows that 330 million urban households worldwide currently live in the substandard housing or are financially stretched because of the housing cost. And in one of the latest reports, the global housing affordability gap is at $650 billion per year. It's a full 1% of global GDP. And the gap is growing by 2025, 440 million urban households, or as many as 1.6 billion individuals worldwide, will face crowded substandard living. So, however, to our thought leaders and entrepreneurs, these housing crises present both a problem and an opportunity. Today, we are honored to have an all-star panel who is the top player and leader in the field of housing innovation. And we are eager to hear your stories about your adventure in the innovation in the industry and how we can build house faster and cheaper so that we can all afford housing. And to join me today is Todd from Gensler, Chicago office, Roger Krulak from Full Stack Modular, New York City, and Patrick Kennedy from Panoramic Interest in San Francisco. First of all, I would like to, the agenda for today's session is that I will ask our speaker to present their work for about 10 minutes, and then we'll have an interactive discussion. Then I will leave about 10 to 15 minutes to the open questions with the audience. Without any further ado, I would like to invite Todd to kick off the show. So give you a little bit information about Todd when he sets up the point. So Todd is from the Gensler Chicago office. He has led the design, technical, and management of projects in varying use groups and skills. His project has received over 20 national and international design and development awards, including a National AIA Award for Housing and a Distinguished Honor Award from the Chicago, Wisconsin, and Arizona chapter of the AIA. And during his career, Todd has performed every function of the real estate development process, acting as owner, developer, architect, contractor, broker, and property management. And his real estate development profile contains more than 75 buildings, 4,000 luxury multifamily dwellings, with a combined value of more than $2 billion. Let's welcome Todd Demiris.
Thank you. So let me start by just saying I'm recovering from a 3-week bout with bronchitis. So if I cough in the middle, I apologize for that. I've told the video recorder that he might have to do some extra work for you to keep you from hearing that. As was just indicated, just a brief background. We already had a great description of it, but I'm an architect, but spent about 18 and a half years working for a vertically integrated real estate development company. We did, what that means essentially is we were both we were the owner, the developer, the architect, the general contractor, the broker, and property manager for 19 developments in those 19 years, about 4,000 dwelling units, 77 buildings, $2 billion worth of real estate, all urban, infill, high density, mixed use, transit-oriented developments in Chicago and in Scottsdale in Arizona. And I joined Gensler about 3 years ago and was asked to work on the project that you're going to see now. Our client had discovered a 3D printer entrepreneur in Shanghai who had developed a concrete mixture and printer head to basically manufacture housing, and we were hired to look at a whole series of prototypes for the United States and Haiti, Ghana, Egypt, and Saudi Arabia, and we put together a whole series of building types. This is one particular module. After we had finished that study, he sold a building to the Prime Minister of Dubai and gave us 6 weeks to design a building and have it fabricated and installed. And so we began looking at how to do that. We were actually the building was printed in Shanghai over a period of 3 days, and then we had to ship it to Dubai in order to have it installed. So you can just see, we had to figure out that, how to do that. It was a whole series of concrete modules. The interior finishes were to be 3D printed. The exterior enclosure was also 3D printed. And that was our concept. You know, I think I said the buildings, the components were printed in about three days, and it was erected in a little over a day and a half, probably 2 full days, quite frankly, in the middle of the night to when it was a cool 115 degrees in Dubai, since we were doing it in the middle of summer. And this just shows some of the components. The printer had the capability of printing product that was 22 feet wide, 33 feet high, and 105 feet long, which didn't do us much good for kind of shipping overseas. Our components were effectively about 7 feet wide and 11 feet tall. They were put in 2 pieces and 24 to 30 feet long. And you can see them after they've come out of the printer. It's a series of layers of concrete that have been set with the printer in sort of a factory environment. Here's the pieces arriving in Shanghai and being installed on top of each other and next to each other. And the white object on the bottom is the finished building. It was actually a 2,500 square foot office building that they used for the PR and events planning folks at the Office of the Future, which is at the Museum of the Future, which is being developed on the Emirates Tower site here. And the interiors of the building are effectively just open office environment. The real key was that the structural core was 3D printed. The remainder of the interior construction and exterior enclosure was traditionally built thereafter just because of really development costs. We had never printed a single component and built this building without any other options. And the real interest, our real desire was to develop a system whereby we could print the entire component of the building, both the interior, the structural core, the outer skin and the interior finishes, as well as all the MEP systems into the print, and really create kind of a sophisticated wall system that a smart system in the exterior that would actually be able to be connected together and bring all the services to the building, and simply connect these components together and build a building essentially that fast. One of these can be printed in about 6 hours, and assembly is as fast as you can assemble in essence. So that's really our goal. We've started working recently with a new group out of France that called X-Tree. They're manufacturing printer heads. You can see a bit of the printer head on the lower right-hand side of the film. And they're really looking at sort of maximizing the efficiency of the skin in concrete to minimize the amount of material that you use. And This is showing their printer. They just use standard robotic arms with a custom printer head, and we have the capability now to print very, very fine objects at faster speeds. The original print we had were layers that were approximately 1 inch thick by 3 inches wide, and now we have the ability to print at about 2 millimeters high by 1.5 centimeters wide, so very thin skins. A lot of very fine detail capability. The particular group, X-Tree, is printing both in concrete and clay. And the clay can be used as a form to pour concrete in, and then you wash the clay away, and you've got a concrete form, and you can actually reuse the clay. So they can do very complex one-off components. The benefit of printing is every single object that you print can be different. So the old concept of modular housing where everything is the same, with 3D printing, that's really not necessary. So it shows kind of the high level of detail that we're able to get. And the other big element of possibility with 3D printed buildings is in terms of the speed of design. We can now design a structure. Today we design structures three-dimensionally as architects, and then we produce two-dimensional documentation for bidding and permitting. Then the subcontractor will get the two-dimensional drawings, turn them back into a 3D object for fabrication and construction. But with 3D printing, we can design in 3D. We can coordinate the whole project in 3D. We know all the information about the building, the surface area, the quantity, how long it will take to print before we ever start. So we can economize the skin. And you can see in the interior of this particular object that X-Tree printed, they really optimized the amount of concrete that's necessary to make the shell structure work. So the inner walls are actually bending to the need that works. And so we can reduce quite a bit of time today, because after we finish designing, we can just press print and end up with a building. And every building, as I said, can be different. The real key today is really trying to develop buildings that really speak to this type of construction. The rectangular form of building, 3D printing allows us endless other opportunities, and really trying to discover what those opportunities is the next step. So that's it.
Thank you, Todd. Hello, thank you, Todd. Our next speaker, if you Google the word modular stackable housing, his name and the work he has been doing will fill the first 2 pages of the Google search. And he is uniquely qualified to lead a groundbreaking industry change, like the movement to off-site built construction for large-scale urban multifamily construction. He has been in the construction industry for over 25 years. And prior to start his own construction full modular, he has spent 12 years at Forest City Ratner Companies as SVP of Mixed Use and Residential Development, entitling and planning over 1,000 residential apartment units integrated into many of FCRC's retail projects. And in 2008, he spearheaded the first R&D project for the modular construction, which led to the creation of FC Modular, and subsequently the creation of a factory and a business to build the tallest volumetric modular building in the world. As a recipient of the Popular Mechanics Breakthrough Award in 2014 for his work on the creation of a high-rise modular process, he has been publicly recognized as a leader in the innovation. Let's welcome Roger Krulak.
This is a serendipitous benefit of the introduction, because one of the biggest problems with the built environment and the way that we create it is that we are miserable with technology, and we haven't been able to integrate it into our process near enough, and I'm going to talk about that a little bit today. for those of you in the audience who are developers, my plea is that it is incumbent upon you to be willing to shift the way that we think about creating a product in the built environment and the way in which we do that. And so this is just a little bit of a current state of construction. Construction costs continue to rise. We talked about the needs for housing structure, and overruns and late deliveries are standard. And as a result of that, and working in New York, which is a high land cost, and I guess it's just not the highest construction cost in the world, if not one or two, we as developers, we're looking for a way to at least control and predict the cost of building products, mostly multifamily, in a dense urban environment. And that's really where the whole high-rise modular process for us started. In order to do that, you really need to change the process from design, bid, purchase, construct process into a completely integrated process. Maybe not by putting in a printer and press print, but much in the same idea, at least moving in the same direction. So I figured I was at MIT, I had to have some statistics. So the current state of the industry, great report from McKinsey, worth reading. And this, it talks about the world economy and how many billions of dollars in the economy it actually represents. For some reason, my slide got cut off, and that's the turquoise is manufacturing. But it basically just says that construction productivity is flat since 1995. And every industry, the total economy is up 2.7 times the 95 productivity, and manufacturing is up 3.6 times 1995, or 2.6 more, 2.6 more. What does that mean? It means the productivity on kind of an hour worth of $25 rate is significantly higher in every industry and very high in manufacturing. And the interesting thing to think about, and I am not a world economist, is the amount of drag that construction, the lack of construction productivity has on the whole world GDP. The fact that we are not productive does affect not only affect our ability to have housing, but it also affects the world economy as a whole. And to my point, this is one of my favorite graphs. It shows expenditures in different industries on technology. And if you look at the very bottom there with all the red marks on it, you see construction. We spend nothing on technology. Well, hunting is worse. But other than that, and to me, this is, having been in this industry a long time, a huge driver. And that really is kind of where our world starts. So our process is as design builders for developers or with developers to create a off-site modular solution for multifamily housing, for the most part, in a dense urban environment. And the reason I say that definition, and that's the tallest modular building in the world, at least for the minute on the left-hand side, and that's the interiors, that's pieces of it, and then that's our factory where we're producing currently. The reason I say that is that transportation is the limitation of size as it relates to off-site built modular construction, at least volumetric. And so doing and building off-site in a dense urban environment where it's very expensive, security, transportation, et cetera, is tough. It's incredibly attractive. On the other hand, in places that are a little less dense and a little more spread out, sometimes manufacturing things but assembling them on site is a more attractive environment. It really depends on where you are and what you're doing. The big issue, again, not to just press print, but our design process creates a 2D design turned into a model, exploded into pieces and parts, which then are turned into production drawings, which we manufacture in the factory, that has all of the knowledge of how long it's going to take to build, how much material is in it, et cetera, so on and so forth. And in the factory, we have adapted a lean process by which we manufacture things task by task, not trade by trade. And we literally break each individual part into sub-assemblies to the extent possible to make sure that we can move the production process along as fast as possible. This is a little nomenclature of our world. We build our multifamily buildings out of a steel chassis. It's a non-combustible product. We build sub-assemblies like bathroom pods and kitchen pods. We actually put the facade on in the factory, we wrap it up, and then we send it out to the site. And these are some of those sub-assemblies. This is our bathroom pod manufacturing area. That's what the design of a bathroom pod looks like. Actually, it as a sub-assembly is being adapted all over the world in a whole bunch of uses, hospitals, concrete poured buildings, et cetera, because the amount of trades that are required in order to do a bathroom is far more than there actually is space within the bathroom to manufacture it. Kitchen pods, the same thing. Something that's always fascinated me, I know that we build kitchens in spaces, but the idea of taking 62 boxes to make a 10-foot kitchen, it doesn't make any sense. And in our factory, we can actually build them as one piece or two pieces, top and bottom, and it makes the process go much cleaner. We also have developed a self-sealing facade system, which eliminates the needs for scaffolding, increases the safety, and also the water tightness of the building. And it's a true, especially in New York, it's proved to be very, very helpful along that side. And scaffolding in New York on a 20-something story building is a couple of $1 million, so it's a nice savings. And that's actually a picture of the top of the building. From below, there were 3 different facades on this one in particular. Thank you.
Thank you, Roger. Thank you, Roger. Our next speaker is a graduate of CRE in 1985, and he is busy building high-density infill housing in Bay Area, San Francisco. Let's welcome Patrick Kennedy.
Great. That's me. All right. Thank you very much. It's great to be here. I see one of my old professors here, Professor Bill Wheaton. That's particularly gratifying for me because I think I got a B in his class, so I'm glad to be back. I've blocked it out. But today I'm going to talk about bringing 21st century ideas to the 19th century, so aptly introduced by my 2 colleagues over here. It's long overdue, and it's nice. I'm very honored to be presenting this here at MIT. As I said, my name is Patrick Kennedy, and I've been doing very high-density infill housing in the Bay Area since I graduated. And the first place I developed was in Berkeley, a place that at the time was described by the Wall Street Journal as a city where its citizens were torn between a desire to overthrow the U.S. government and a quest for the perfect croissant. And interestingly, since the election of Trump, nothing has changed, so we're back. But when I introduced infill development there, they took a very dim view of it, and the local newspaper produced this cartoon. And for those of you who don't get it, that's me on the right, the developer. I'm used to working in skeptical, hostile environments, but I was able to persevere in Berkeley and developed quite a bit of high-density infill there. To give you an idea of just how successful the city was in killing off developers, that little project there, a modest 4-story building, was the first rental housing project by a private developer in downtown Berkeley since World War II. That building right there, which was built in 2001, was the first high-rise development in downtown Berkeley since 1972, and the local press called it a Stalinist monstrosity and monument to civic corruption. Since then, we've been focusing on low to middle income housing, entry-level housing for urban dwellers. That's what we perceive to be the greatest need, and we're working on, we just finished a high-rise micro-unit project in 2015, and we're working now on workforce housing and housing for the homeless. And I'll talk a little bit about these in a second. The first project, micro apartment project we did was a 23-unit project that used prefab as well. So we are there in solidarity with you, Roger. This was built in 2013. It had 23 305 square foot apartments and is a rental. From that, we got bolder, and more importantly, we persuaded our lenders that they wouldn't go bankrupt financing us, and we built the first high-rise micro apartment project in the United States, which is rather immodestly called the Panoramic. But it had 254 square foot units and 524 square foot 3-bedroom units, both of which we concluded were too big. So we've modified, and I'll talk a little bit about that in a second. All of our decisions about housing have been informed by what we have witnessed as 4 trends that's taking place in the Bay Area, Boston, Los Angeles, any place that has a booming job market and is in a city. The first of these trends is delayed household formation. Basically, young people are not getting married now as early as they did, which was used to get married in 22, now they're getting married at 28. I'm well acquainted with this phenomenon because in the Bay Area, 31% of all millennials, and that's millennials 21 to 34, live at home. And I have a very immediate experience of that as my 23-year-old daughter, who graduated from Stanford, is now unemployed and living at home, and we are wondering what we are going to do. Another important phenomenon is a lot more people are living alone. They're living in smaller places, but they're living alone. This is true in San Francisco, it's true in Manhattan, it's true all over any major metropolitan area. The second major trend that we've recognized is home purchasing is not only harder, but it's also, in some cases, less desirable. The best example I could dig up from that from my slides was this 2,550,000 fixer-upper in downtown Palo Alto. And note that it went $623K over asking price, and this was when? In last month. That's one reason why young people aren't buying houses. But another reason is they're burdened with structural debt that's going to make it very difficult for them to get launched. You know, the failure to launch may be the next great crisis in our democracy with this large cohort of millennials that can't seem to get on track. The third phenomenon that we've noticed, I've noticed in San Francisco, is people aren't driving as much and more importantly aren't buying cars. San Francisco was the founding city of Uber and Lyft, and there it's very clear that owning a car is not only unnecessary, but it's actually more expensive than not owning a car and using Uber and Lyft. This young woman moved up from LA, car capital of the world, and concluded she was saving $11,000 a year. The fourth phenomenon that I've noticed among young renters, and other renters for that matter, is they just don't have as much stuff. And that's pretty easily explained because if your world is wrapped up around an iPhone, you don't need that much more stuff. On top of all this, in the Bay Area, which we have a huge job growth, is the problem of affordability. Now, it's not only affordability for rents, but it's also the high cost of construction. The Bay Area is such an expensive place, we cannot lure plumbers from other parts of the country to move there at any price, because they know that even though they may get paid 4X on their salary, they're going to be paying 5X on their housing. So the problem is getting worse and worse. And not too many people shed tears for Google engineers, but they are, in fact, living in trailers. I'll show you that in a second. The other corollary, or the other simultaneous development that is a result of this lack of affordable housing, is the incredible problem of homelessness, which is only going to get far, far worse in the next 5 years. San Francisco is going to, has had probably one of the more publicized ones, but their numbers are going to skyrocket because as of now, very little new development is being undertaken. Now, the response in the marketplace. The response to the marketplace is what you might imagine, but it's gone to even more extremes in places like San Francisco and the Bay Area. Here we have a gentleman leasing space in a tent. I love the title of this, by the way, The Scholar's Inn. It's a block away from campus on Airbnb for $50 a night, $1,500 a month. This is last year. And just last week, Mountain View, where I gave a presentation on affordable housing and modular, was discussing the Google engineers and what they call the working homeless who are living in RVs alongside their parks. And you must admit we've gotten to quite a place when people that make $100K a year can't afford housing in a city. How do you know you have a housing crisis? When a Google engineer lives in an RV, I guess. The other more general response among non-techies and other civilians, you might say, is represented by this cartoon, which is in a local paper about a month ago. And I'll take it through you very quickly. This is a conventional 2-bedroom, living room, bath house. Now, in San Francisco, the way that young people adapt to the housing crisis there is as follows. They take this bedroom and make it into a hacker bunk room. They take this room and add 2 bedrooms. They carve up the living room into 2 more bedrooms. They carve up the closet into a bedroom. And this is my favorite one. They put a bed over the bathtub. This is not too far from the truth. There are constantly articles about young people living in laundry rooms, walk-in closets, and the like in the Bay Area. The solution that I think is a solution is as follows. And that is, we need to build housing that's car-free, that has what I call micro-DNA in it, and that's modular. The first of these, car-free, is easy. It's also economical because, and we deal with it the following fashion. We don't provide any parking in our buildings. That simplifies things dramatically and it lowers costs. The second component of what I think is necessary for affordable housing is what we call micro-design. Now, by micro-design, it doesn't have to mean tiny. It happens to be tiny in many cases in our buildings, but it's not necessarily just super small. What it is, more importantly, is super smart. And to illustrate that, I'd like to show you a studio apartment that our project manager, graduate of MIT, Zach Shore, 2012, stayed in when he first came to work for me, a studio apartment in a high-rise in downtown San Francisco called Nema. It was 680 square feet, and I think he paid $3,600 a month for that. We have taken that same 687 square feet and distilled it to what we call essential housing, and that is the bedrooms, bathrooms, kitchen, and living areas. And we took that 687 square feet and concluded that we did not need 27 square feet of it, and we built and are building 660 square foot, 4-bedroom apartments in San Francisco now. Now, you may think, my God, that's horrific, 70 square feet. But we have built this unit. You can come see it at our office in San Francisco before you pass judgment on it and experience it. We build prototypes, we furnish them, we design it as carefully as someone designing an iPhone to get every component right. And that's actually why we know enough is just enough for this particular clientele. The final and last thing is we need to standardize modular design and construction. If you look at how we manufacture nowadays in every other industry, shipping, airlines, cars. This is a Tesla factory, by the way, in Fremont. You can see it's incredibly sophisticated. It's enlightened. It's dynamic. It doesn't require many people either. Fast forward, or not fast forward, shift over to see a typical residential construction site in my hometown, and you see that. There it is. That's the best we could do. And in fact, if you look at residential construction in the United States, you can see that the last major technological advance was in 1833 in Chicago, when stick frame, balloon frame construction was popularized, and which enabled the vast expansion of the West. Now, I want you to pay attention to this gentleman here, Rufus, and this gentleman here, Zebediah, because we're going to fast forward them 184 years, and that's where we are today with the same process. You know, give them a nailing gun and a hard hat, and they would be rocking and rolling in a few minutes. So we think disciplined modular, that, by the way, we like smaller modules. They have to be intermodal in size, flexible in design, and easily relocated if necessary. And this, we think, is the factory of the future. Now, well, you're just going to have to take it on faith that this shows the construction process. There's the site. It's coming. Okay. Well, we build the site. We order the steel. The modular is built. It's put on a boat. It's stacked on a job site, and it's skinned, and that's the entirety of the construction process. Our typical modulars look like this. They resemble a container, but they are not containers. These are specially made, specially reinforced, and brand new. By the way, you know, container technology is interesting, but no California engineer will sign a project with used containers. It's a non-starter to produce large numbers. Streamlined, you'll have to just take it on faith that that's streamlined production and delivery. And unfortunately, I didn't show you how quickly we can build, but we can build 1 floor a day, and the outside of the building will look like this. And that's a really important thing about the modular technology that we use. The insides are done. They come with linen, furniture, coffee makers, coffee cups, everything. And that's the inside of a micropad, which we just built in November, and which we're hoping to pitch to cities throughout the United States as a solution to homelessness. The fit and finish in here is better than anything I could ever produce on the job site, even with Florentine craftsmen. It's a simple production, and it saves about 40 to 50% of the time. Roger, you can probably chime in on this. The last part about the modular that I happen to think is necessary is that we need to standardize and have discipline in design. And as it is, we have 3 designs. We have the micropad, we have the duo, and the suite. Now, this concept is better understood in California when I put it in terms that they understand, which is the In-N-Out Burger model. How many of you have been to In-N-Out Burger? Okay. Well, for those of you that have not been to In-N-Out Burger, I would say it is called slow fast food. It's the fast food place that Anthony Bourdain goes to before when he gets to LA and when he leaves LA. It's a great place. It's a model of efficiency. It's a hip place to work, and it's very, very economical. And when you have modular design and standardization, you can then put some serious numbers up for housing. And this is an example of what we could do if we built all studio apartments with 1 boat, 10,000 units on that boat alone. So, to conclude, I'd like to remind you of the 3 things that I think are necessary to build affordable housing: car-free, micro-DNA, modular. Now, this is my throwdown, smackdown challenge to MIT. The software in the construction industry was largely designed in the 20th century, right, with Euclid v. Ambler, the famous zoning case, 1926. The hardware we just saw, that comes largely from the 19th century, stick frame construction. Isn't it time that we entered the 21st century? And thus is my challenge to MIT to get with the program here. Thank you very much.
Thank you, Patrick. Thank you, Patrick. So you hire all the A students? Is it true that the A students all work for the B students?
You know, I didn't ask Zach his grades. Yeah.
Probably.
That's funny. I'm sure he was. Do you remember? No, did you have Zach as a student? Zach Shore, he was class of 2013. You had them all, you're right.
Oh.
Yeah. You know, I didn't ask him his grade in Bill's class in particular because I knew it was irrelevant, right?
But this is a perfect grade card that you show after all this, the work you have been doing.
What's
this is
that?
really fabulous. This is your
card.
real grade
Oh,
card.
this is the real report
Yeah.
card, right, yeah, right.
Thank you so much
Thank you.
for your fabulous work. And I would like to take some minutes to ask some questions, and then we can open the question to our audience. So first of all, I think all of your presentation imply one of the problem in the construction industry is that it has just don't have enough incentive for the innovation. So I want to ask you, how did you started your career as to push these groundbreaking technologies in such a traditional industry? And what is your biggest struggle? I want to ask Roger to start first.
Okay, so the question was, why did I get?
How did you start it?
How did I
And
start
then,
this?
are you worried? What is your biggest struggle?
I'm the CEO of a company. I'm worried all the time. But at the same time, I'm from the Midwest. My great-grandfather was a carpenter in Russia who would be totally comfortable on most construction sites in New York.
Right.
I tell that story all the time. And when I got to New York, the land costs, the process costs, the carrying costs, the dollars were incredibly intimidating to me. And as a developer working for Forest City, the cost volatility based on how much construction was going on made the process very, very unpredictable and unachievable. How do you know how your development is going to work out from a cost return perspective if you have no idea what the construction costs are going to be? So that's where it happened. So that's really where I started to think, well, there's got to be a better way, and convinced the leaders at Forest City to let me try to come up with another solution, which isn't new, by the way. I mean, modular housing happened in Germany after World War II. Moshe Safdie built the Habitat in 1967 as his thesis from college. So
you proposed a startup within a big corporation.
Exactly. And that's really where it happened.
I see. And what's the struggle? What do you think is most difficult?
The struggle is exactly what I said and what we've all said, which is it's a paradigm shift. You really need to think as an industry that the whole concept and the way that we have, especially in the United States, it's actually getting better in other parts of the world.
Right.
They're adopting it quite successfully, but we have got to jump out of there's a design and engineer side, and there's a developer finance side, and then there's a construction side. It's all one process. And as we feel, it's really design, manufacture, construct. And whether you're printing a building, it's that process. It's how do you get from what you conceive of to the end product without having these silos of processes. That's the disruptor. That's what you need to disrupt in order to have change. And that's what I struggle with. This is like talking to people like, oh, this is faster, cheaper, safer. Why don't you want to do it? Oh, well, I've always done it another way. Yeah. That's the biggest struggle.
I see. I have another question for Patrick. I used to work at the City of Vancouver, and I really like your idea about a car-free. However, as a policymaker, I feel always this constant barrier. So if someone proposes a car-free, it's just impossible to get a city regulation, prove this to get passed, because it's just people always talk about it, but when it comes to the regulation, it's just impossible to break through. How did you manage to convince the city government, the regulator?
Well, San Franciscans, as a general proposition, dislike cars as much as they dislike Republicans. So it was already there. They were ready. They were ready to go.
I see.
Yeah.
So you didn't.
Cars are the bugaboo already. So I didn't have to do anything. The one thing that San Francisco did to advance development is to get rid of car parking requirements.
So what's your strategy to work with the public policy sector to foster this, to foster your vision for this housing crisis and the solutions?
Well, I would like them to adopt our 3 designs for public housing because they're already vetted. They've already been, we've hired, you asked why we got into development. I got tired of paying architects and structural engineers to design the same generic rental apartment building. It seemed crazy. Why not build one and then use that design again and again? So this is a variation of that. But I think the affordable housing people in California especially need to standardize their designs for rental housing, entry-level rental housing, and just go with it, and then beat up on all their suppliers and builders to get the cost down. You know, bespoke development is unnecessary for rentals. They need off-the-rack development, so to speak.
I see. Todd, so your 3D printing approach is very different from the modular stackable. Actually, you made an emphasis that we are not modular because we can do whatever the designer do. So have this technology has been used for the housing besides the commercial and the office space? What do you see its implication in the housing market?
Well, as I mentioned, we first started studying the technology for use in the housing industry, developed a series of prototypes for several different world, markets and climates and so forth that have, the goal was to solve the housing crisis with 3D printing because we can manufacture for locations that have no natural resources, have no skilled labor, have just suffered natural disasters, and be able to provide housing at a fairly fast rate with 3D printing. So that was really the start of it, and the commercial application came later just because we wanted to get a building built, I think. But its advantage is the fact that you can do custom variations. People can have what they want, in essence. The complexity is free, is really what we've described it as, because each building could be potentially different one to the other, because you're in the old way of doing form, precast construction, if you will. You built a form and poured concrete in it, and you wanted to reuse that form over and over and over and over again to minimize the cost of the construction of that form. But with 3D printing, there is no form. You just print whatever shape you want. So it provides unlimited flexibility and variety for
So what's the barrier
housing.
to scale it up, like for other parts of the world? I think the work is done in Dubai. Like, how do you see it's getting into the housing market, for example, here, local?
Yeah, so there are 3D printing companies. They're basically small entrepreneurial groups around the country. There's a Branch Technologies in Chattanooga, Tennessee, for instance, is printing plastic, carbon fiber reinforced skeletal frames that they can apply finish to and insulation and run wiring and so forth. They're trying to develop housing. As I said, it's when the urban environments were first constructed, we built out of brick, and we went up 6 stories because that's as high as we could go with a bearing wall building, and then all of a sudden it was discovered we could, and stairs, everybody went up and down the buildings with stairs, and then the elevator was invented at the end of the 19th century, and steel structures came in and tall buildings, and it really took a while for the architects and the industry to understand what this new technology could do and how should it be organized and put together. The first tall buildings built with a steel structure they looked like they were bearing wall buildings because that's what everyone knew how to do. But 3D printing provides for a whole new level of building and design paradigm that we haven't really discovered yet. It's in its infancy, trying to figure out what should it be because of this new capability.
Thank you. Patrick, may I invite you to ask each other a question that you want to ask your peers? Maybe you ask a question for either
yeah,
Roger or...
Sure. Well, I have one for each. Roger, how do you deal with the volatility and the unpredictability of the development cycle, specifically the entitlements process? So I say, I want a 100-unit building, Roger. I love your stuff, and I'm ready to write a deposit. You say, great. I get sued by my litigious neighbor that wants to slow down the project. And it's in California, that could be a year, 2 years, 3 years. It all depends. How do you deal with that? Because that's one reason why I never wanted to go
Sure.
into the ownership part of the modular part.
It's a diversity issue. So we
Yeah.
basically have a series of products, not three, but
Yeah.
we try to, and the markets that we address are hotels, dormitories,
I see.
and
Less predictable.
no, well, yeah, hotels, dormitories, and multifamily rentals,
Right.
and then we have some secondary products that follow slightly different economic cycles,
Right.
with the idea of trying to have enough product going through the factory, and it's working so that you can achieve that.
Right.
And then if necessary, bathroom pods, just whatever you need to. It is true, we need to feed the beast, so it's an
Yeah.
issue that needs
Right.
to be addressed.
Yeah. I mean, I asked that because the first firm we used ran into that problem when they had a backload of orders that suddenly were all jammed on account of litigation from labor unions. So, Harry.
Roger, do you want to pick one of the speakers to ask your question?
I want to ask you the first question, which is, I'm totally fascinated. No, it's you contrasted the kind of modular housing versus printing, and I understand that. And so how do you think the growth of the process of printing buildings? What I didn't understand is, if you're printing the buildings, are all of the systems printed as well? No, right? So how does that integration process work, and how do you see it growing? Because I understand it's several years behind a lot of other processes, but the portability of it is incredibly attractive, right?
Well, we have the ability to print anything. I mean, we're printing heart valves for people. So even today, you could have multiple printers on arms printing multiple materials simultaneously. So the capability exists, it just hasn't been put into production yet to print a structural core, interior finish, exterior shell. Original thought was, we could just print the conduit right in the system. We don't actually do conduit, we just print a concrete hole to run wire through. I mean, ideally, we'd come up with a system whereby we can print the wire as well and eliminate, as much, manufactured, labor to put the, piece together and so forth. So there is the potential for printing everything, and I think if you were printing, if we had an order for 10,000 units in Egypt, for instance, which has a significant housing shortage, we would have a variety. I don't think we'd have 10,000 different buildings, but you certainly don't have to have all 10,000 identical. So there's flexibility. And with concrete, you do have the potential for stackability. You can, pile these up and build them tall.
Todd, do you want to ask a question?
Yeah, for Patrick, I was just wondering, so are you developer, architect, contractor, or just developer?
No, we're just developer.
Okay.
One man, one art. That's it. Yeah, we like to buy milk. We don't want to own cows.
All right.
Yeah.
So, I mean, is that, you still have to have some architects, engineers for getting the building on site, and you have to buy your modules from somebody? Do you use the same people over and over again?
We do, and we sub out all the professional stuff.
Right. Okay.
We don't have we just everyone in our office is just developer centric. We hire out the architect, the engineering, all that stuff, because you get better people if they do it all the time for other people, and you get access to the people who are doing the most innovative stuff.
So Roger, you're more, my experience when I was working development, we were the owner, architect, developer, contractor, broker, property manager. So the way we made the system efficient is we just did it all ourselves to avoid anybody screwing it up.
Right.
That seems to be part of your model, or?
It pretty much is. I mean, we work for developers, but it is sort of design, build, construct, or design, manufacture, construct, really. So that is one of the ideas. And we do actually work with other professionals, but we don't need to. So we have, I mean, we can, and we're happy to do it, but our process is pretty holistic in the solution, meaning give us a program, and then we'll manifest that program. And if it was like Patrick, then we wouldn't even have to think about it. He could just order his In-N-Out burger, which, by the way, I highly recommend if you haven't eaten. That would even be, that's the goal, really, is to have.
Would you build his modules for
Sure,
him?
Yeah.
happily.
Yeah, no,
Not in LA.
I do.
I'll put it on a boat if he orders 10,000. I'll actually put it on a boat and send it to the Panama Canal.
Okay, because of the time limit, I will have 10 minutes to invite the audience to ask questions to our speakers. Yes. Yeah.
Question for primarily Patrick. So California is very regulatory, obviously, and the way I look at a lot of entitlements, it's either facilitative or regulatory. So have you run into a lot of bumps from the regulatory framework on this kind of product? Because one of the most difficult things is getting city engineers to buy off on your plan, the fire department, all those kind of things. So not only you're fighting a modular battle, but you're fighting a battle for the city to sort of accept this kind of housing. And that risk would seem extreme to me, because if you go down that route and they don't buy into that process, you could really hit a big bump. So what are your thoughts there? And do you see a timeline on this where you fight, and then the world becomes facilitative versus regulatory and you take off?
Right.
What do you see as the future of this?
Yeah, I think, answer to your first question, the state of California is very enlightened and supportive of this. The head of the Housing and Community Development Department is a guy named Ben Metcalf, a K-School grad that comes from the public policy realm and not labor realm, which is a key distinction. And he is embracing new technology, and he's giving all of his employees marching orders to make it happen. So and the good thing about that is then you can take the city out of the equation altogether, because they don't have any jurisdiction over modular. So, but it is slow going, and the graveyard of modular developers in California is large and growing to this day, but I don't think people have approached it with the same kind of discipline and specificity. Hamburger, the cheeseburger, and the double-double, and that's it. No ordering off menu, nothing. That's it. And that, I think, has a chance of succeeding. So we'll see. We're going to be building our first project in August using this technology. And at that point, we may see a wave of new interest in it. Part of the hard problem is getting banks to finance it and to find out who, in fact, bears the loss if the module burns up between the boat on the truck on the way to the job site. Who's going to eat that loss? And as it turns out, it was pretty simple. It was going to be me. So for the first time, we're having to do that. But after that, we will get things in place to establish this as a way. It's a new way of doing business, or it's a different way of doing business in California. But I think it will take off just as fast as Uber and Lyft took off, because it's the right thing, right product at the right time.
Okay, yeah, you go.
Just to follow up, one of the issues that we in Boston are running into, as far as modular is concerned, is the resistance of trade unions.
Oh, yeah.
Clearly, the carpenters are not very happy to see this catch on. Do you have any suggestions or ideas about how to deal with the trades on this particular approach?
Well, one thing I'm sure you can talk about this, Roger, much better than I can. And we never concede to the trade unions. However, we will use trade unions on site. And in fact, 2 out of every $3 spent on a modular project is spent on site. So I think part of it is education. They don't realize that this is going to open up a whole new area of development to them that they're currently shut out of because it's way too expensive. But it is a huge issue, and trying to persuade a plumber, the head of a plumbers union, to embrace technology is like trying to get a taxi driver to embrace Lyft. So.
Roger?
I have a little different experience about that. In New York, a couple of things. We are, by the way, in our factory, we actually are union, but there's some big exceptions. Everybody in our factory is a trade associate, although they're members of a union, so there are no trade jurisdictional issues within the factory. They're all manufacturers of housing. And at the same time, we are part of the building trades. So the building trades accept everything we do, and on site, if it's a union job, we're agnostic about that, but if it's a union job, obviously it's union workers. Right. And they, to the credit of Gary LaBarbera, who's the president of the Building Trades Association, was very forward-thinking, and he literally got to them to adapt and embrace that. So we've been very lucky in that way.
Yeah, that's not true in California. It's quite a different program.
We're willing to fight that battle a little bit.
In regards to concrete printing and larger structures, how do you deal with structural integrity? Are you able to introduce rebar, things of that nature, as the projects get bigger and you're actually printing them?
So the building that we printed actually did have rebar set in the normal fashion. So the printer arm was moving around, and then they set a rebar cage over it as it was printing, and it kept going, which is a limitation within the system. And the ability to print basically steel, there are printers in, I think it's MX3D in Amsterdam is printing steel bridge. So it's essentially a robotic arm that's printing weld, and it'll print a bridge and walk across the bridge as it's printing it. So there is a capability for printing rebar, but I think Skylar mentioned in the keynote yesterday about new materials, and that's actually one of the important things in development in 3D printing is developing new materials. The new people we're working with in France, for instance, they're printing their concrete with stainless steel reinforcing, so it's almost like steel wool inside of it, and that'll act together very similar to the rock and string idea, so that you're printing the material has the structural capability of both compression and tension in the ink itself as it's printing a product.
In designing your micro units, have you given any thought to co-living spaces, similar to what WeWork is doing, but for housing, in which the private space, the bedroom is really small, but then you have shared spaces for kitchen and other amenities?
We do that. When you don't have parking, we usually give over the whole ground floor to common spaces where people can have a wine bar, hang out, watch TV, and so forth. But that's it. I mean, I happen to think price is the best amenity, and that you should stop you can stop when you've done that for people if they live in a city. But
in order to make it even smaller, you take some functions outside of the unit.
Oh, I see.
The kitchen, put it in, like shared kitchen.
Yeah. Our four bedrooms have a modest living room, a modest dining room. I suppose they serve that function. But common spaces for cooking, in my experience, are always a disaster because the housekeeping standards gravitates to that of the lowest level. And there's no getting around that unless you hire full-time maids, which we don't want to do.
I see, yeah.
The driving force, is there a thought of how we can avoid some of the mistakes that were made in the 60s and 70s, making these huge housing projects that quickly turned into slums and very undesirable places to live?
I think part of the issue with that is the whole concept of mixed use, to really create vibrant communities and activities, not putting all the housing on a 380-acre parcel and then everyone takes a train or walks to the office area and so forth. Today, in the development of our cities, it's all about mixing uses together, and the most vibrant areas, the places that everybody wants to live today, are usually the historic areas of cities where they're doing manufacturing. People are living in converted buildings that used to be manufacturing. There's food and beverage all over the ground floors. There's trucks coming in to deliver equipment. There's people walking up and down the streets and with baby carriages, and it's that vibrancy and that authenticity that everyone's looking for. So I think provided we don't try and segregate all these different parts and we just mix them together, we'll help avoid that problem in part. Yeah.
One last question. Yes, the gentleman at the back.
We looked actually at some of these modular solutions for projects in Africa, and particularly for an hotel. Roger, you mentioned hotels, and the hotel operator even showed that this fantastic modular bathroom, where basically is one piece. But then the word was once the project is done, if someone breaks the sink, I have to replace the whole bathroom, and the room goes out. How is this new solution integrating with what the available maintenance is around? How do you deal with that?
So I'm going to answer your question by somebody who's been in construction and development their whole lives. First of all, the interesting thing about modular manufacturing, and that it is manufacturing, is that our as-builts, in other words, our drawings, are actually how they are. So if you've ever built a building or owned a building and had a set of plans and nothing is where it's supposed to be because the trades decided where everything was going to go as long as it was meeting the specifications. Right. Our plans, plus or minus 1/4 of an inch across all systems. So to answer your question, if you have a problem and there's a leaky pipe or there's a broken circuit, you know exactly where it is. So I see that as an advantage rather than a disadvantage.
Yeah. And by the way, on our components are all made with standard manufactured toilets, sinks, everything. In fact, we're sensitive to the issue that we're getting these built in China, and people are a little terrified of that. But so we have all American brand fixtures, Leviton, Chicago Plumbing, Kohler, and so forth. But they're all made in China, by the way, all those units. So it's
even growing.
Even growing. And so any of those components can be replaced by off-the-shelf stuff that you can get in an American hardware store.
Okay, thank you, everyone. I would like to conclude our session by a big thank you to our 3 speakers. Thank you so much for exciting talk.